right, here is EI Lesson 3, Properties of Integer Exponents and Multiplying and Dividing Integer Exponents. Very, very similar to the last two lessons. We are learning more integer exponent rules. So I'm going to just help you understand. Here's our example. We have 3 squared times 3 to the 4th. When you have the same base, the base is the number to which a power is raised. So 3 is the base in this situation. When you are multiplying two numbers of the same base, but different powers, it turns out you can use this to your advantage and add those powers together. I'll show you why. 3 squared is 3 times 3. 3 to the 4th is, remember we're multiplying by, here's 3 times 3 on the left, 3 times 3 on the left, multiplied by 3 times 3 times 3 times 3, which is 3 to the 4th. 3 times 3 times 3 times 3. If you remember, multiplication is associative, so we don't really care very much about these parentheses. They're not necessary, so we can drop them. I will do that. Drop, 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 drop. Cool. And, okay, what is 3 to the 3, or 3 times 3 times 3 times 3 times 3 times 3? That's 6 of them, so this is actually 3 to the 6th. While in the last, we raised a power to a power we multiplied, clap, clap. Here we are multiplying numbers of the same base, and so we add their exponents together. I had some fancy fun song for that, but I forgot. You can come up with one. It'll be great. So this is 3 to the 6th, which is 729. Very helpful to have a calculator to do that. All right, so we're going to do a few more examples. If you were taking notes, you would take notes right now, very much like this. You would say, when I have some base A, some base, to the b power times some same base, must be the same, and to another power, they can be the same if you want, or maybe they're different, then the result will always be a to the b plus c. We could talk about why that's the case and how this is addition of powers and the last one was multiplication. We'll get into that. I will have you understand that we have a to the b times a to the c is a to the b plus c. We're adding powers together when you are multiplying like bases. Whereas in the previous lesson, we multiply powers. Raise a power to a power, multiply, clap, clap. So fun. Okay. Examples. I'll go through a whole bunch of examples to give you some experience on how this works. There is another rule that we'll get to when we get to this point. Okay, so 2 to the 3rd times 2 to the 2nd, that is simply so many 2s. 2 to 2 times 2 times 2 times 2. 5 2s. 2 to the 5th, which is 32. Okay, and then we have 3 squared times 3 to the 5th. This is tedious. 1, 2, 3, 4, 5. How many is that? Well, 2 plus 5 is 7. This is 3 to the 7th, and I don't know that one off the top of my head. So let's use my handy-dandy calculator. 3 to the 7th. That does not say 3 to the 7th. Try again. 3 to the 7th. 2187. Cool. This is 4 to the 2 times 4 to the 0. We do know that 4 to the 0 is 1, so this is just 4 squared. Or we can add the powers together. 4 squared plus... squared 2 plus 0 is still squared. This is 4 times 4 times 1, which is 16. Oh, single base, sorry. 4 squared, which is 16. There we go. Okay, once again, we're just going to add our powers together so that we don't have to worry about this. I will write it out, actually, and I'm going to do it a little bit zoomed in so that's easier to see because I need a little more space. So we have 3 times 3 times 3 on the top. Oops, too big. 3 times 3 times 3 on the top. And on the bottom we have 3 times 3. This is on the bottom because of the negative sign. How many of those are going to cancel? Well, 2 of them. We're left with plain old 3. This is 3 to the 1. You can also determine that by saying I'm going to add 3 to negative 2. And that will be 3 to the positive 1. All right, so coming back out for the next few here, we have 2 to the 3rd times 4 squared. This is a common problem seen on tests such as the ACT, where you'll have to actually solve some situations like this. We can't combine these together because they don't have like bases. However, 4 is 2 squared. 4 is equal to 2 squared. So we can turn that 4 into 2 squared, which would make this 2 to the third times 2 squared squared. We can do that. What is 2 squared squared? Well, that's 2 to the fourth. So that's 2 to the third times 2 to the fourth, which is 2 to the seventh. I'm not even going to write out the expansions for most of the rest of these because, okay, I'll do it. 2 to the seventh. 3, 4, 5, 6, 7. There you go. 2 to the seventh, and that is 128. Okay, 3 to the fifth over 3 squared. We just showed you what happens when you have some on top and some on bottom. Some are going to cancel out. I will show you an example of what that looks like over here on this side. Okay, so we have 3 to the fifth. How many threes? 1, 2, 3, 4, 5. Over 3 to the second. 1, 2. How many cancel? Those 2. We're left with 3 to the third. So the rule is, based on this observation, that when you have a power on top and a power on bottom and you're dividing same bases, then you subtract the exponents. You subtract the powers. So the rule in note-taking form, hint, hint, take notes, is if you have a to the b over a to the c, that is in fact a to the b minus c. A to the something over a to the something else, you subtract the powers, top minus bottom. Just like that. I'm sure there's a cool song you can come up with, like my raise a power to a power multiply. I'm sure you can come up with something cool. Tell me in class. It'll be fun. Anyway, expanded form, this is going to end up being 3 times 3 times 3, which is 3 to the third, which is 27. Okay, same thing here. We're going to subtract 7 from 5 and get 2, so this is 5 times 5, which is 25. Oops, sorry, 5 squared. 5 squared, which is 25. And this guy, 4 to the 3 over 4 to the 3, well, anything divided by itself is plain a 1, so we're just going to put it as a 1. If you want to be really fancy, it's 4 times 4 times 4 over 4 times 4 times 4. But you don't need to write it because you know it's 1. Okay, this guy's a little more fun. What is 3 minus 5? Well, it's negative 2. So this is 2 to the negative 2. We'll write that here, which is 1 over 2 times 2. And that is 1/4. Once again, we're going to use our convert 4 to powers of 2 dealio trick. 4 to the 3 is in fact 2 squared to the 3 because 4 is 2 squared. 4 here, that's a 4. 4 to the third is 2 squared. 2 squared to the third. 4 to the third, 2 squared to the third. So 2 squared to the third, if you multiply, raise a power to a power, multiply. That's 2 to the 6th there. So we have 2 to the 6th over 2 to the third, which is in fact 2 to the third, 2 times 2 times 2, 2 to the third, which is 8. This is so fun. All right, once again, we're going to do this guy. We're going to multiply those together. That is 2 to the third squared. What do? We multiply. It's 2 to the 6th, which is the, what did I say that is? 64. Right, and you can write it out if you like. 3 to the 2nd to the 4th. This is 3 to the 8th. And I don't know 3 to the 8th off the top of my head. I think we may have calculated that one already. 3 to the 8th. That is 65, 61. I don't believe we calculated that already. And if you want to write it out, you take 3 to the 3rd. I don't know where that went. There it is. Look at that. Probably would have been just as fast to write it. And 2 to the 10th. Oh, to the 0. Okay. Whew. What happens when you raise something to the 0? It's 1, period. You can also multiply the powers together and get 2 to the 0. It's still 1. Very cool. This is 4 to the negative 1, which is 1/4 squared, which is 1/4 times 1/4, or 1 over 4 times 4. We can also write this as 1 over 4 squared, or you can write it as 4 to the negative 2, which is 4 to the negative 1 times 2. Still, you get 1/16 no matter what. And that'll do it on practice for this lesson.